This is the video for section 1.5, interpreting, estimating, and using the derivative. So in this section, we will get sort of our first view at what might we actually want to use the derivative for, and what's some useful information the derivative can tell us. So remember that the definition of the derivative, if I'm given a function f, then f prime of x is equal to, you fill in the blank, limit as h goes to 0, f of x plus h minus f of x all over h. And there's also some notation that we sometimes use for the derivative called differential notation. So sometimes we denote f prime of x as df dx. Sometimes we call it dy dx. Sometimes you might see capital DF. Lots of notation, but it all means the same thing, that we're taking the derivative of f with respect to x. Okay, so the question is, if I have units on a function f and on the variable x, what are the units on f prime of x? And the way to figure this out is to think about where f prime of x comes from. Namely, it comes from the difference quotient when I take the limit as h goes to 0. So let's think about the units on the difference quotient itself. So the units in the numerator, f of x plus h minus f of x, well, those are just the units of f. And the units in the denominator, h, that's just the unit of h. In other words, that's just the unit of the independent variable. So, for example, if s is a position function and it measures meters at time t in seconds, then what would the units on the derivative, s prime of t, be? Well, it's going to be the units of s, which is meters, divided by the units of t, which is seconds. So it's meters per second. And that relationship is general, so it doesn't just have to be a position function. And here we'll see sort of a business or economic example. This is activity 1.13 in your book, but I'm just going to do it here in the video. So let's say a company makes rope, and the total cost of producing R feet of rope is C of R dollars. So my first question is, what does the equation C of 2,000 equal 800 mean? Well, that means it costs $800 to make 2,000 feet of rope. So that's just interpreting what the function notation means in this setting. My input is 2,000 feet. I put that into the cost function. I get out $800. So it costs $800 to make 2,000 feet of rope. Next question. What are the units on C prime of R? Now remember, those are going to be the units of C divided by the units of R. So it's going to be dollars per foot of rope. So units of C are dollars, units of R are feet of rope, so dollars per foot of rope. And for the last part, we want to estimate something. So I'm going to suppose that I know that C of 2,000 equals 800. So in other words, it costs $800 to make 2,000 feet of rope. And suppose that I also happen to know that the derivative at 2,000 is equal to 0.35. I would like you to estimate C of 2,100. So there's a couple of ways to do this. The first way to do it is to think of what the derivative formula is. So C prime at 2,000, well, we have an exact formula for that in terms of limits, but it's approximately equal to the slope of the secant line between 2,000 and 2,100. In other words, it's approximately equal to C of 2,100 minus C of 2,000 divided by 2,100 minus 2,000. So what do I know in this equation? I know the left-hand side is 0.35. I don't know what C of 2,100 is, so I'm going to leave that alone. I know C of 2,000 is 800, and 2,100 minus 2,000 is just 100. So now I can solve for C of 2,100. And so I get 100 times 0.35 is approximately equal to C of 2,100 minus 800. I'll add that 800 to the other side, so I get 35 plus 800 is approximately equal to C of 2100. So C of 2100 is around $835. And again, interpret that properly. That's saying that it costs around $835 to make 2100 feet of rope. Oh, yeah, that's what I have here. And notice that makes sense, at least based on what we know about how much it costs to make 2,000 feet of rope, which was $800. Certainly it should cost more to make 2,100 feet of rope. So, and it probably shouldn't cost all that much more. So this seems like a reasonable answer that we're getting here. But there's another way to find an estimate for C of 2100, and that's just if we use the units of the derivative. So C prime of 2000 equals 0.35. Units on that are dollars per feet of rope. So what this is saying is when I'm at the production level of 2,000 feet of rope, it costs 35 cents or $0.35 to make the next foot of rope. So C of 2100, well, that's approximately equal to the cost that it took to make 2,000 feet of rope plus the cost that it would be to make another 100 feet of rope. So we have 100 feet are my units times $0.35 per foot of rope. So indeed, we see those units would cancel and we'd be left with dollars in that second term. So we know that C of 2000 is 800, and then 100 times 0.35 is 35. So again, we see that the cost of producing 2,100 feet per rope is around $835.